and welcome to the Lezlie Show. Woo! Hey, you guys, I was just curious, are you a bit concerned about the way gas prices are going up these days? Seems like every time you go to a pump, it's higher and higher. Well, I gotta tell you, I found a place in Santa Maria where it's $1.39. You guys need to go there. Yeah, it is Taco Bell, but anyway, today we have the greatest show. We're going to be talking about drones today, and we have a very special guest today, Victor Rasgado. Woo! Stay tuned. Hey, Victor, welcome to the Lezlie Show. How are you?
Thanks, Leslie. Thanks for having me. I'm doing great.
Great. Thanks. Well, can you tell our audience today what UAS stands for?
Sure. UAS stands for Unmanned Aerial Systems, but let me kind of expand on that a little bit, because what I want to do is I want to give the audience the opportunity to hear about the profession that I'm part of, which I absolutely love, and like I was saying earlier, has been part of my life for almost the last 30 years. So I'm part of the Geomatics group. Traditionally, it's called surveying and mapping.
Okay.
So the UAS and what we're going to talk about today with drones is just really a new tool in our tool bag for mapping the surface of the Earth. So for all of you who are interested in an awesome career, the field of geomatics in the last 30 years has just expanded to include digital mapping, GIS mapping, so geographical information systems. Google Earth is a prime example of a GIS system where you can go in, zoom into an area that's been digitally mapped. Oh. So with UAS, Unmanned Aerial Systems, and UAV, Unmanned Aerial Vehicles, now what we can do is map at a local level, and we can take these drones out, take photography of an area that we're interested in mapping, put that all into a digital format, and create data from all that information and all the photography that we take.
Awesome.
And so expanding on that, that's what really got me into this profession, Geographical Information Systems, GIS. I was really interested and fascinated with digital mapping when I was attending the geography program at San Francisco State.
Okay.
That led me into surveying and mapping because they had a GIS component at the University of Alaska, Anchorage, where I eventually got my Bachelor's of Science in Surveying and Mapping.
Well, Victor, tell us about yourself and how you got interested in the drones, or the UASs, I believe they're called.
Okay, well, that's an interesting story because it involves Hawaii. I got lucky. Well, I was fortunate. I was blessed to have been asked to take part in a grant at the Hawaii Community College in Hilo. And part of that grant and part of the responsibilities I had, I was a GIS coordinator for the Big Island. And what we were doing was bringing and innovating education. We were taking existing STEM programs, so science, technology, engineering, and math courses, and providing those online, condensing the courses. Part of that was to go out, collaborate with other public agencies, University of Hilo, Hawaii, as well as schools in Maui and Kauai, to put together this program where we provided GIS mapping courses. So GIS stands for Geographical Information Systems.
Okay.
As part of that, I was fortunate, as well as our students, where we were invited to take part in mapping a lava flow that was occurring, and that was actually endangering the town of Poa in Hawaii on the Big Island. Part of what we were doing is we were providing surveying and mapping base points, while the geology and the geography students and the professors from UH Hilo, they were using drones to map this lava flow. The interesting thing about this particular lava flow is it usually comes in at knee height, and over time, over several hours, it actually inflates like a cake. So what they were doing is they were taking flights, at regular intervals. They were having us take measurements on the ground, and then they were comparing that data from the drone to our conventional land survey measurements to see, okay, what's really going on here, and can we actually get accurate data from drones to map this lava flow? And the answer was yes. I mean, they came back and reported to me that, you know, they were accurate to an inch over an area that was pretty much a mile long. Part of what they discovered is they could actually predict where these lava flows and breakouts were to occur. And so this was part of a collaborative effort with the county agencies. We were giving them real-time information about the lava so that they could then allocate their resources to protect infrastructure that was in place. I was amazed by the whole technology. I've been in surveying and mapping for the last 30 years, and this, I recognize this is a game changer. If we could get our own information using drones, and it's accurate to, you know, an inch, wow, that really is a value to a surveyor, to engineers, to the public agencies. And the great thing about it is it was part of a, you know, emergency response. You have a lava flow, you come in, you map it, you give the decision makers real-time information so that they can go out and allocate their resources in an effective way.
Interesting. Okay. So when you take the pictures and you have this information, what exactly do you do with it then? Well,
let's back up a little bit. So what I do for, I manage the Stantec office for the Geomatics department in Santa Barbara. We work in conjunction with our civil engineers, structural engineers, and then what they ask from us typically is, hey, we have this project, we like it to be mapped, we need the information so that we can do our design work. With UAS, we can take photography. Typically, we weren't able to do that before, and that's the game changer for us as surveyors. In the past, we had to hire out, you know, a regular aerial photography company, come in, take the aerial photography, do the mapping, and then we would supplement that information with our own land-based conventional survey work, put all that information together, and then hand that over to our civil engineers. We can now do that all in-house now with our drones. We can go out, take aerial photography, put all that information together, create the mapping that needs to be extracted from that information, put that together into a map, and then hand that off to our civil engineers over at Stantec.
Say some of the major benefits are of drones?
Well, like I had mentioned, the emergency response. I don't know if you've seen, well, in Houston, they've been using drones to map and help allocate resources for the flood victims there. I'm assuming the same thing's going on in Puerto Rico and all the other areas that have gone through some sort of natural disaster. That's one aspect. I mean, then you can take it into, so I work for Stantec in Santa Barbara. We're a community development group. So we do geomatics, we do land surveying, we do civil engineering, we do transportation engineering, we do structural engineering. So any one of those disciplines can actually use this drone mapping, this data collection to enhance and to develop and to make smart decisions about whatever it is that they're fixing or designing or planning for. A good example actually is the Napomo skate park that's being developed right off of West Tef Street. We went out, we did some flights. The civil engineers took that information, kind of came up with a really cool conceptual plan. And so now we're actually now in the civil design phase for that skate park in Napomo.
Oh, interesting.
So a couple examples there, yeah.
Okay. Well, what are some other industries that are into the drones?
Agriculture, they're a big user of drones. They use drones to map soils, the health of soils, the health of plants. on Hawaii, they're using drones to track invasive species, not just plant invasive species, but also insects, because they have a real problem there with invasive insects. And so I know part of what Hilo is doing is they're mapping a particular bug that attacks the banana plants there in Hawaii. So they're using that information to make decisions and to decide, okay, what's the best way to control these invasive species.
Okay, so when you do get all the pictures that the drones have taken, what do you do with all that information then?
Well, it's data, and that's kind of the really cool thing about drones and what they bring to my profession and the profession I've loved and the profession I've been part of for the last 30 years. It's another tool in our tool bag. And so let me take just a moment to kind of elaborate on what Geomatics is and what I do.
Okay.
So I'm a professional land surveyor. I'm licensed in the state of California as well as the state of Hawaii. I make maps.
You make, okay.
So traditionally, I go out, I send my crews out, they go take measurements on the ground. They take that information, we map it, and then we provide that information to whoever's asked for that information.
I see.
I think a real simple kind of example that I give, and I used to give to my students in Hawaii, when you go to a restaurant and they give you, those activity fun sheets, and then one of them is you connect the dots.
Yeah.
That's exactly what surveying is. In fact, on the simplest, in simplest form, Washington, Lincoln, Thomas Jefferson, they use a plain table map or plain table with a tape to map points on the ground. And it's almost like, when you go to school and you have that grid paper and you have the X and the Y, and then you map and you have the points 1 and 1 and 0 and 0, and then you connect the dots. It's the exact same thing, but we do it on the surface of the earth. Okay. And we're interested in actually what's out on the ground, whether it's man-made features or ground features, natural ground features. We're mapping all that information. The drones make it easier to pick up that information versus somebody walking a site that maybe, 100 acres, 10 acres. We're using drones to map that area, and we're getting data that's accurate to an inch. Okay. In a lot of cases.
So Victor, tell me, do you ever have challenges when you're doing this? What would be some problems you might come up with?
Well, the first challenge is, the FAA restrictions. I mean, part of what we need to do when we fly drones commercially is we have to have licensed pilots. So our team, I'm fortunate to be part of a team. We were one of the first firms to get licensed pilots. So that's one aspect. In order to do this, you got to be a licensed pilot. You have to take the FAA Part 107 test, pass it, before you can even take the controls of a drone.
Oh, okay.
After that, now that you know the rules and regulations, is the airspace restricted? So an example of restricted airspace, anywhere close to an airport, within 5 miles of an airport, that's restricted airspace. Nobody should be flying a drone within, the confines of an airport for obvious reasons. We don't want any accidents, with planes.
Exactly.
Then there's weather, sunlight, because we are taking photography, and so we want plenty of sunlight when we're taking our photos. Wind is another aspect that we need to be aware of. Is it too windy to fly a drone? Because safety is a big thing that we take into consideration when we're flying our drones. We need to make sure that we have the public safety in mind at all times. And then from a side, then there's flying over the public. You're not allowed to fly over the public in most cases. So the conditions have to be ideal for flying a drone that meet the FAA regulations for commercial flights.
Okay. Well, what would be the difference between a commercial and a residential drone?
Well, recreational.
Or, excuse me, recreational drone, yeah.
Yes. So, aside from the obvious, if you're a commercial drone pilot, you're doing it to make some sort of income.
Right.
Whether it's photography, video, or data collection for mapping purposes. That's kind of the commercial side. You know, you're there to make profit. You're there to collect data. You're there to have that data as a commodity to provide to your clients or the engineers or whoever you're working for. On the recreation side, those are the remote control pilots. And I mean, I don't know if you've seen drone racing, and that's become a big new kind of thing out there. Those drones can go up to 120 miles per hour. Oh. They're going through obstacles. So you're doing it for fun. You don't care about the commercial aspect. You're doing it strictly for fun. Some folks, they just go out, they want to take photos of, this beautiful area that we live in on the Central Coast. So my brother, he's got his drone pilot's license, and he likes to go out to Shell Beach and take photos of, the beach, the sunsets. So that's kind of the main difference. I think one side's really doing it for fun, the other one's doing it for profit.
Okay, so if you have a recreational drone, do you need a license for that as well? Is that what you're saying? And explain exactly how you get the licensings for the commercial and the recreational.
Well, recreational, you don't need a drone license. No, you need a license. Well, let me put it to you this way. I think it's a good idea for everyone to know the FAA rules, and because those rules and those regulations are pretty much what kind of governs the safe aspects of flying a drone. Okay. How to read sectional charts, how to read weather reports, how to communicate with the tower, how to maintain an altitude with certain conditions, whether it be wind or updrafts, downdrafts. So that's really important, I think, for any drone pilot to, whether you're recreational or commercial, to know. Mm-hmm. But aside from that, as far as recreation, it's strictly for fun, and it's
you don't need a license.
You don't need a license, but it's always a good thing, because you never know. Somebody may come and approach you and say, "Hey, I have a project. I really need a drone pilot. Can you help me out?" Right.
Okay. Well, how do you feel the drones have changed surveying?
Well, it's been a game changer, Leslie. I mean, seriously, I've been doing this for 30 years, and in those 30 years, Geomatics, it was called land surveying or surveying and mapping. It's now called Geomatics, which is the science of measuring, the surface of the Earth. In the last 30 years, we've gotten into, GPS technologies, global positioning systems, so mapping and measuring with satellites. We've had 3D laser scanning come into our kind of realm, where you take a terrestrial scan, it shoots millions of points, and you can actually accurately map the inside of a building. Wow. Now with drones, we can actually now map larger areas and collect even more data. So one of the really cool things from the data that we extract from the photography, which some folks call FOTAR, we can get orthographic photography, we can get videos, we can get photo stills, we can get 3D point cloud. So kind of imagine like a multitude of points that you can see in 3D. So I go out and I map your house. I can take all these different photos, put that into our software, our UAS software, the Unmanned Aerial Systems software, get a point cloud, and actually give that information to an architect so that they can accurately map and do a renovation on your house. Oh. Or like we were saying, civil engineers can use it to then map and create a new roadway. Mm-hmm. So it's a game changer. Wow. It's when I was in Hawaii and I was part of that program, they estimated that the GIS, the geomatics, and the mapping field would grow 20% in the next 10 to 20 years. That was before engineering. That was before drones really kind of hit the scene. Now with drones, with geographical information systems, the digital mapping, it really provides more data. We can get that data to the civil engineers or the design, the architects, whoever it is that's using the information. so that they can make smart decisions. They can create some really cool stuff with this information.
Awesome. Well, where do you foresee this going in, say, 10, 20 years?
10 to 20 years, you know, it's the sky's the limit. It's hard to say, but really it's for my industry, for the geomatics industry, and for those folks who are interested in a really cool career, it's really going to change the way we map. It's going to change the way we provide this information to our clients. It's all going digital, and so all this information where we used to go out and we used to map and then bring it in, we're going to have 3D point clouds. We're going to be able to map in 3D. We'll be able to, you know, provide information quicker. We'll be able to provide aerial photography in a quicker manner. Mm-hmm. So for my industry, for the geomatics industry, I think it's really going to take us into a new realm where we're really going to be providing more data, more information to the decision makers, like I said earlier, mm-hmm. to make smart decisions and hopefully, you know, make things better for the public. Mm-hmm,
mm-hmm. I was just curious too how fast the drones go and how far up do they go?
So for the commercial drones, so the drones that we use, I think our Phantom 4 Pro maxes out at 44 miles per hour.
Oh my goodness.
But we don't obviously map in that speed. You know, that's kind of its top speed, but we like to take things slow and steady to get the overlap and everything that we need for our photography. Mm-hmm. But like I had mentioned, the drone racing, those can get up to 120 miles per hour, and they're only kind of, you know, yay big. And they do some really amazing things. I mean, some of the courses that they come up with for this drone racing, I mean, I saw one video where they were going through a football stadium, and they were using the ins and outs of the tunnels in the stadium as part of their course. Oh. And I know actually at my old school there where I was teaching at the Hawaii Community College, they're looking at making drone racing as part of their curriculum for the Office of Continuing Education and Training.
Do they have drone racing around here in Santa Maria or Santa Barbara? I've never seen that, but I'm definitely
You know, that's a really good question. I don't know, but I was thinking the same thing. I actually would like to be part of that. I know my son Victor would like to actually get his own racing drone and take part in those races. Mm-hmm. And I'd like to just be part of it. It would be fun to be there to watch those things fly.
I remember I bought a drone about, 6 months ago, but I crashed it. It's pretty easy to crash them and spend a lot of money on one, and then you go, oh no, the thing crashed. I'm just wondering, do you need to spend a lot of money on one?
No, you don't. I mean, here's the thing. I was actually just talking to one of my surveyors because he really wants to get into it, and there are courses available. I know there are online courses that will kind of give you the basics of the FAA regulations. There's some remote piloting software that you can purchase to get good at, you know, flying. Nothing beats, you know, the actual, you know, getting it and flying it. The bigger drones are more stable, so they're easier to learn on, believe it or not. You can get one at Radio Shack for, you know, $60, you know, $20. Those are really hard to control, and I know that from experience because I've taken I've hit just about everything. But you know, but the bigger ones are more steady. Those are the ones that, you know, most commercial firms use. You have a little bit more leeway with those, and they don't go flying off. You know. They can maintain their altitude and stay stable while you kind of figure out all the knobs and the controls. It really does help to be a gamer. If you, you know, if you're an Xbox or PlayStation kind of person, yeah, and you've gone through those flight simulators, my son Victor has told me they're pretty much the same controls that control the game, whether it's a flight game in Xbox or the drone. So yeah.
So what type of money are we talking about for a bigger drone?
Well, you're talking, you know, for something decent, you're talking $1,500. Okay. For a decent drone that you can actually use on the commercial side. So, or you can go. We have a S1000. That was, I think, when we purchased it, it was like $8,000.
Oh my goodness, okay.
However, that drone will lift 25 pounds. you can switch out sensors. You know, we're looking at putting a multispectral camera on our drone, so that you have flexibility with that one. So that's why the price goes up.
Okay.
But you know, the $1,500 would definitely get you in, and actually, you know, you can make a living at that. That's what my brother plans on doing when he retires from the state.
Okay. Well, I feel that we've learned quite a bit about drones and surveying and where the world's going with these drones, and it's been a real pleasure having you on the show today.
Well, thanks, Lezlie. I appreciate you having me on, and again, you know, I want to really take the time to talk about this industry that I'm part of, and like I said, you know, if anyone out there is interested, there are several schools out. Fresno State has a 4-year program in geomatics. Hawaii Community College has a 2-year program in architectural engineering and CAD, so that you kind of get everything. You get architecture, you get surveying, you get engineering, and you get the GIS, the Geographic Information Systems, as part of that program. And I believe there's another 2-year program in surveying and mapping down south, I think in Pasadena.
Okay.
So there's lots of opportunities, as well as, you know, the online courses that anyone can take.
Okay. All right, well, thank you very much.
Well, thank you, Lezlie.
All right.
Thanks for having me. It was a pleasure. I enjoyed it.
I did too. Take care.
Thank you.
Hey everyone, thanks for joining us today. Next week we are going to have the greatest show. We're going to talk about basketball. I've got Cameron and Hunter Walker on, and Christina Sandiagos. It's going to be a great show. Stay tuned. Thank you, and don't let anyone take your mojo. Woo!